Okay, chapter 1.4 is on solving equations. Your objective for this chapter is to solve equations and to solve problems by writing equations. Alright, first we got to talk about the properties of equality. First, there's the reflexive property. So that's like a number equals itself. So we'll say A equals A, or, for example, 5 equals 5, obviously. Then there's the symmetric property, which states that if A equals B, then B equals A. So if 1/2 is the same thing as 0.5, then 0.5 should be the same thing as 1/2. Then we have the transitive property. It says that if A is B and B is C, then A should be equal to C. So if 2.5 is equal to 2.5 and 2.5 is equal to 5/2, then 2.5 is equal to 5/2. Transitive is when you cut out the middleman. Substitution says that if A equals B, then you can replace A with, that's a C. If A equals B, then you can replace A with B and vice versa, which means and the other way around. Okay, so if A equals B and 9 plus A equals 15, then 9 plus B equals 15. So we're moving on to the next few properties of equality. If there's the addition property of equality, which means you can add the same thing to both sides. So if A equals B, then A plus C equals B plus C. So if X equals 12, then X plus 3 equals 12 plus 3. You can add the same thing to both sides. Subtraction property of equality says you can subtract the same thing from both sides. So if A equals B, then A minus C equals B minus C. If X equals 12, then X minus 3 equals 12 minus 3. Then there's the multiplication property of equality, which states that you can multiply both sides of an equation by the same thing. And then there's the division property of equality, which states that you can divide both sides of the equation by the same thing. So A over C equals B over C. And I'm not going to finish filling those out. I think you got the point. Alright, so example 1, I have a one-step equation. First, let's talk about the vocabulary. The solution of the equation are all the values that make the equation true. And inverse operations are operations that undo each other. So if I've got X plus 4 equals negative 12, what's happening to X is adding 4, so we're going to undo that and we're going to subtract 4. The inverse of add is to subtract. And I end up with X equals negative 16. You can also check that by plugging it in for X, and you get negative 16 plus 4 equals negative 12, which is true. So you know that your answer is correct. Alright, so solve this equation. We're going to divide both sides by 12 because we're multiplying by 12, and the opposite of multiply is divide. And so I get B equals 18 over 12, which reduces to, if you reduce it by 2, you get 9 over 6. But if you were to reduce it by 3, you get 6 over 4. If you were to have reduced it by 6, you would get 3 over 2, which is the reduced fraction. So that's a one-step equation. Now we're moving into two-step or multi-step equations. So what we want to do is simplify everything we can simplify first. So that's going to be maybe this, got to get rid of the parentheses. So we'll distribute the 3. And we get negative 27 plus 6y equals 3y minus 9. I have more than one y, so I need to combine those. If they're on opposite sides of the equal sign, you have to do the opposite to one to move it over to the other. So I'm going to have to do negative 3y. And I get negative 27 plus 3y equals negative 9. Now what's happening to y? First it's being multiplied by 3 and then it's being subtracted by 7. So to undo these, we're going to first add 27. And we get 3y equals negative 9 plus 27 is 18. Then we divide both sides by 3. And we get y equals 6. So I'm just doing inverse operations all the way down. You do have to think a little bit more up here on what to do first, the distributive property, and then moving the y's to get together. But as you do more, you'll get more accustomed to doing that. All right, let's do another one. For this one, we've got two sets of parentheses that we need to get rid of. So we're going to distribute the 3 and also distribute the negative 2. And I know some people don't know the difference between a minus and a negative. That's because there is no difference between a minus and a negative. It's the same sign. If it's minus 2, that's the same thing as plus negative 2. So when I distribute this minus 2, I need to distribute the negative with it. And that gives me 6x minus 3 minus 6x plus, not plus, negative 2 times 4 is negative 8 equals 11x. And then, if I combine like terms, I get 6x minus 6x, which actually goes away, and then I get negative 3 plus negative 8, which is negative 11, equals 11x. Now, I have to get x by itself, so I'm going to divide by 11, and I get negative 1 equals x. Okay, so this is on page 28 in your textbook. We're going to write an equation before we solve it. This is always more difficult because you have an extra step thrown in there. So you have to think a little harder on these. If you'll look in your book on page 28, you can read along with me and see the picture. I just can't put it on the video. But it says flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Place in Brussels, Belgium has a perimeter of 200 meters. What are the dimensions of the flower carpet? So what we've got is a rectangle flower carpet, and on one side it tells you it's 3x, and on the width of it tells you it's x. So in words, they're telling you that the perimeter, which for a rectangle is 2 times the length plus 2 times the width. So 2 times length plus 2, oops, not plug, plus 2 times width is 200. And so for length and width, it says to define a variable, but we've already been given variables. So we're just going to use those. So the length is 3x. So we're going to do 2 times 3x plus 2 times the width, x, is 200. So when we defined our variables, we also wrote our equation, so we don't have to do the next step. And now we'll just solve it. So 2 times 3x is 6x. Plus 2x equals 200. So the first step in solving an equation is to simplify the equation. Then combine like terms. So it's going to be 8x. And then do your inverse operations. So we'll just divide by 8. And you get x equals 25. Which means that the width is 25. But the length is 75. So if they ask you width and length, you can't just say x equals 25. You actually have to answer the question. Okay, what if the flower apartment had a perimeter of 320 meters? The equation would be the same. All we would change is what the perimeter was. So it'd still be 2 times 3x plus 2x equals, but this time it'd be 320. And I'd still end up with 8x equals 320. That side of the equation wouldn't change. And if you divide by 8, you get 40. Which means the width is 40, but the length, is 3 times 40, which is 120. Example 4, no solution equations or identities. An identity is an equation that's true for every value of the variable, so you would say all real numbers. And no solution is an equation that's never true. So what you need to do to figure these out is to always simplify first. So I've got like terms, and that's going to leave me with 3x. 11 minus 7 is 4. So 3x plus 4. And then over here I've got like terms 6x and minus 3x, which is 3x plus 5. Well, I've got 3x on opposite sides. If you ever have the same number, sign, and variable on opposite sides, they are going to cancel. So you can go ahead and mark those out, and I get 4 equals 5, which happens to be never true. It is not possible for 4 to equal 5. And then B, combine like terms, 6x minus 2x is 4x. And over here, I get 4x plus 5. Well, I've got 4x plus 5 equals 4x plus 5. It's the exact same thing on either side, which means this is going to always be true. I'll let you do this yourself. If you'll pause the video and try this on your own, I'll tell you the answers in just a second. Okay, if you're following along, A is going to be never true. Obviously, you're going to get something that doesn't equal, and then B is going to be always true. A lot of students hate literal equations. What a literal equation is normally a formula that has more than one variable in it, but this is a very functional application for science, and it comes in handy when you, especially like for this example they gave you, what you have is the formula to change Fahrenheit to Celsius. But what if you only had this formula and you had to change Celsius to Fahrenheit? Well, to do that, all you'd have to do is change it in the formula, and you'd have a new formula. So what we're going to do is take our equation, and we're going to rewrite this as Fahrenheit in terms of Celsius. Well, right now, we have 5/9 times these parentheses equals C. So if I'm going to do the inverse of 5/9, what if I just multiply by both sides by 9/5? That's going to cancel here, and I get 9/5 C equals F minus 32. Well, to get F by itself now, just add 32. Now on these, you do kind of have to think smarter, not harder. So there was another way to do this, but it wasn't smarter, so I didn't do it that way. You can get yourself in a big mess with these equations if you don't think about what you're doing before you do it. So let's try that one more time. I have Kelvin to Celsius. If I have Celsius and I want to change it to Kelvin, but I want to go the other direction, so I need to solve for for C. So I've got my equation. How do I solve for C? Well, I get C by itself, and that means I'm going to have to move this 273 to the left-hand side. So C equals K minus 273. Okay? Alright, now I need you to pause the video and do these 5 questions on a separate sheet of paper. You have to show your work. If you don't, I'm just going to throw it in the trash. You're not going to get credit. If you do you have to attempt every problem. I understand if you don't know how to do every single problem because you haven't been able to ask me questions, but you have to give me an attempt to every single problem, and that does not mean writing the problem down.